Look at this flooded paddy field in India. When the seasonal rains arrive on schedule, the landscape bursts into life, and crops thrive exactly as intended. But that predictability is disappearing. Across the subcontinent, temperatures are crossing 45 degrees Celsius, forcing people to seek cover from an unrelenting sun. Then, without warning, the pendulum swings the other way. Waist-deep floodwaters drown urban streets and stall public transit. Roughly 60% of India's agricultural land relies entirely on the natural rhythm of these seasonal rains. When the cycle breaks, the broader economy suffers right alongside the farmers. Why are these life-sustaining cycles suddenly swinging between severe droughts and extreme floods? To figure out why the weather is breaking down here on the ground, we have to look up into the invisible 5-layered engine operating directly above us. This chart breaks down the air you're breathing right now. Earth's atmosphere is a blanket of gas pinned to the planet by gravity, made up of 78% nitrogen and 21% oxygen. It's divided into 5 distinct layers. Starting at the very edge of space is the exosphere. This is the absolute limit of the atmosphere, providing a frictionless space for our artificial satellites to orbit. Drop down a level and you hit the thermosphere. This layer bounces radio signals around the globe and hosts the glowing, charged particles we see as auroras. Below that is the mesosphere. It acts as a physical shield. The friction here is so intense it burns up incoming meteors before they can reach the surface. Next is the stratosphere, home to the ozone layer. This band of gas absorbs harmful ultraviolet radiation from the sun, preventing massive cellular damage to life on Earth. Those upper 4 layers protect us from the vacuum and violence of space, but it's the bottom layer, the troposphere, that actually builds the climate we live in. The troposphere is Earth's weather engine. It holds almost all of the planet's water vapor. It drives the daily shifts we call weather, and over a 30-year average, it establishes the long-term patterns we define as climate. Here is how that engine works in India. During the summer, the landmass absorbs massive amounts of heat. As the air near the ground warms, it becomes lighter and rises, creating a vast vacuum of low pressure near the surface. That low-pressure void aggressively pulls in heavier, cooler air to fill the space. Huge currents of moisture-loaded wind rush in from the Arabian Sea. This massive seasonal transfer of moisture is the southwest monsoon. From June to September, it delivers the vast majority of the country's annual rainfall. But the moisture needs a trigger to fall. As those wet winds sweep inland, they slam directly into the towering ridges of the Western Ghats. This creates the orographic effect. The mountain range forces the wet air sharply upward. As it rises into colder altitudes, the water vapor condenses into dense clouds, dumping heavy rain on the coastal windward slopes. By the time those winds finally crest the peaks and drop down the other side, their moisture is spent. They descend as dry, warm air, leaving the interior plains sitting entirely in a rain shadow. When winter arrives, the temperature balances flip, and this entire wind pattern reverses, a cycle that dictates India's 4 distinct seasons. Billions of livelihoods and the national economy hinge on this precise thermodynamic engine running exactly as nature intended. Today, human industry is heavily interfering with that engine. Power plants are burning fossil fuels at immense volume, pumping carbon dioxide directly into the troposphere. At the exact same time, rapid deforestation is systematically wiping out the trees that would normally filter those emissions out of the air. More exhaust and fewer filters rapidly thicken the bottom atmospheric layer with dense greenhouse gases. These act like insulation. Solar heat radiating off Earth hits this thickened layer and gets trapped instead of escaping. The entire atmospheric engine is now running dangerously hot. That excess heat starts a devastating chain reaction. High in the Himalayas, ancient glaciers are melting into expanding lakes. That melting ice pushes global sea levels higher, while the overheated air supercharges evaporation. The result? Cyclones that batter coastal villages, and monsoon rains that fall in concentrated, destructive bursts instead of steady cycles. The total amount of greenhouse gases you are responsible for is your carbon footprint. Shrinking it means shifting to renewable energy, using public transit, and prioritizing conservation in everyday choices. The atmosphere is vast enough to shield us from the absolute zero of deep space, yet fragile enough to be broken by our daily habits. Reducing our emissions is the only way we have to cool the engine and preserve the climate that keeps us alive.